Hey guys, okay, so I'm gonna go over the problem for the practice team test, and again, just go ahead and skip to any problems that you missed. So for number one, you want to isolate what's being squared. So you want to add 12 to both sides, and then you get 2/3 x minus 6 squared equals 54. And then you want to get rid of this 2/3, so you multiply by 3/2, right? They're reciprocal. And then you get x minus 6 squared, and then 54 divided by 2 is 27, and then times 3 gives you 81. And then now that this what's being squared is isolated, then you square root both sides, and then you get absolute value of x minus 6 is equal to the square root of 81. And then you set two equations, so then you have x equals, and then the square root of 81 is 9, and then x minus 6 equals -9. Because it's the absolute value, you need to make your two equations, and because it's x squared, there's usually always two. Often there are two answers. So then you add 6 to both sides, and you get your first answer of x equals 15, and x equals -3. And those are your two answers. Okay, and then for this next one, there's something in front of this is a quadratic, so you need to solve it using a quadratic method. Usually it's factorable, and since there's something in front of the x squared, we're gonna use the area model and diamond to factor. So the 6x squared goes here, this -5 goes here, you multiply them and get -30x squared, and then the middle term goes here. So then -10x and 3x multiply to -30x squared and add up to -7x. And then you can see here, these are 10 and 6 are evens, and they both have x's, so 2x, and then 2x times 3x is 6x squared. 3x times 1 is 3x, and 2x times -5 is -10x. And so it factors to 3x minus 5 and 2x plus 1 equals 0. And then from there, you can make your two equations. So when this equals 0, you get one answer. And then when 2x plus 1 equals 0, you get your other answer. And then you add 5 and you get 3x equals 5. So one of your answers is 5/3. And here you subtract 1. You get 2x equals -1. And then you get x equals -1/2. So those are your answers there. Okay, so for this one, it has fractions. So you need to multiply by a number that will get rid of all of them. So 36 is divisible by 4, divisible by 9, divisible by 3, 9. So then you want to multiply each one of them. So 3x is the numerator for this one. And then 36 divided by 4 is 9. So you would do 9 times 3x. And -2 is the numerator for this one. And then 36, or we'll do it this way. So 36 divided by 9 is 4. So then 4 times 2. And this one, the numerator is x. And 36 divided by 3 is 12. And this numerator here is 58. And 36 divided by 9 is 4. And then now you just solve this equation. So 9 times 3x is 27x. 4 times 2 is 8. And you have 12x. And then 4 times 58 is 232. And then you want to subtract 12x from both sides. And then you get 15x minus 8 equals 232. And then you add 8 and you get 15x equals 240. And then divide both sides by 15 and you'll get x is equal to 16. 15 times 16 is 240. Okay, so number 4 is similar to 1 in that you need to, so your x is here trapped underneath a root, so you need to isolate that first. So subtract 8, and then 3 times the square root of 3x plus 4 equals 15. Now divide both sides by 3 to fully isolate your root. And you get root 3x plus 4 equals 5. Okay, now that your root is isolated, you can square both sides. And then you get 3x plus 4 equals 25. And then you subtract 4 from both sides. And you get 3x equals 21. And then divide by 3. And you get your answer of x equals 7. Okay, moving on. Okay, so you want to isolate this absolute value first. So kind of similar to the squared and square root, because your x is kind of trapped in this absolute value. So you add 16 to both sides, and then you get negative 4. You rewrite that higher. Negative 4 times the absolute value of x minus 3 equals negative 32. And then you divide both sides by negative 4. And then you get absolute value of x minus 3 equals 8. And that does make sense because your absolute value should equal a positive number. So you keep going and make 2 equations. So you have x minus 3 equals positive 8 and x minus 3 equals negative 8. And then you add 3 to both sides, and here you get x equals 11. And here you get x equals negative 5. And those are your 2 answers. Okay, so this one's similar to the previous one, except for it's an inequality. So you still need to isolate what the absolute value. So subtract 3, and you get 2 times the absolute value of 8 minus x is greater than 16. Then divide by 2, and then you get that the absolute value of 8 minus x is greater than 8. Okay, from here you make 2 inequalities. So the first one is 8 minus x is greater than 8. And the other one is 8 minus x and then you set it equal to -8 because it's an absolute value, but since you changed to -8, you also need to flip the sign. And then you solve each one. So this one, you subtract 8 from both sides and get -x is greater than 0. And then you need to divide by -1. So 0 divided by -1 is still 0, but because you divided by -1, you have to flip the sign. And then that's one of your inequalities. And then this one, you subtract 8, and then you get -x is less than -16. And then you divide by -1, and you flip the sign, and you get +16. So these are your two inequalities, and then you can see what you want to do is you put those numbers on your number line, so those are your boundary points, and then you use open circles because they're greater than and less than, and then less than 0 is this direction, and greater than 16 is this direction. So your answer is x is less than 0 or x is greater than 16. Okay, so now here's a quadratic inequality, and so the first step is to set it equal to 0. So subtract 18 from both sides, and then you get 14x squared minus 11x minus 15 is less than or equal to 0. Okay, and then we want to factor. I'm going to do that down here. A little higher. Okay, so you want to put the 14x squared here, the -15 here, and then you multiply these, and then you get -170x squared. Is that right? Nope. 210. Okay, and then you put the -11x here. And then two numbers that multiply to 210x squared and add to -11 are 21 and 10. So then that's -21x and +10x. And then you can see these are divisible by 7. So you have 7x times 2x is 14 squared, and then 2x times 5 is 10x, and 7x times -3 is -21x. Okay, so this factors to 2x minus 3 and 7x plus 5. Okay, and then you put, and then those create your boundary points. So when 2x minus 3 is equal to 0, that's going to be a boundary point. So when x is equal to 3/2, and then 7x plus 5 is equal to 0 will be your other boundary point. So subtract 5 and divide by 7. So you get -5/7. So you put that one there. And that one there. And then you'll have, because it's less than or equal to 0, you'll have solid dots for your boundary points. And then you want to check the signs for each of them. So you want to test a number in each section. So we're going to test, see, -1 is over here, right? And then 0 is in between there because this is a negative number and this is a positive number. And then a number that's easy to plug in that's bigger than 3/2 is 2. So those are the numbers that I'm going to test. And if you plug in -1, you'll get -2 minus 3. So that's going to be negative. And then -1 in here will be -7 plus 5, which would be negative. And a negative number times a negative number will be positive overall. And here, if you plug in 0, you'll get negative. And then if you plug in 0 here, you'll get positive. And then a negative times a positive is negative overall. And then if you plug in 2, right, you'll get 4 minus 3, which is positive. And then here you'll get 14 plus 5, which is positive, and positive times a positive is positive overall. So then we want to shade all the areas that end up being less than or equal to 0. So all the numbers, all the sections that are negative, and so that's just this one section. So that's the area that we shade. And then that determines how you write your solution as an inequality. So since it's everything in between -5/7 and 3/2, then your answer is x is in between -5/7 and 3/2, and including those numbers, so equal to because of the equal to. And that's your answer. Okay, so for this one, it's a compound inequality. So you want to, basically, I would just isolate x in the middle. So you want to add 5 to get x by itself in the middle. And if you add it in the middle, then you got to add it on the right and then on the left. And then you get -2 is less than 4x, which is less than 24. And then you divide by 4. And then -2 divided by 4 is -1/2. And then 24 divided by 4 is 6. And then you just want to like place those on here. Okay, and then those are going to be open circles. An open circle at -1/2, an open circle at 6. And then this means that it's shaded in between. And there's your answer. Okay, next problems. Okay, so this is a system, and you can see it's like set up to be solved by substitution because this expression is solved for y. So you want to plug it in for y here. And then you have 2x minus 3y. So write 3x minus 17, because that's what y is, equals -12. Then solve this, and remember your answer for x will be your x coordinate of your point of intersection. So then that's 2x minus 9x plus 51 equals -12. And then combine like terms, that's -7x plus 51 equals -12. Then subtract 51 from both sides. And you got negative 7x equals negative 63. And then divide by negative 7. And you get x equals 9. So your x-coordinate of your point of intersection is 9. And then to find the y-coordinate, you plug it into either of these. This one's a little easier. So y equals 3 times x, which is 9, minus 17. So that's y equals 27 minus 17, which is 10. So your y-coordinate is 10. So your point of intersection is 9, 10. So up here. Okay, and then you can graph each of these. So y equals 3x minus 17, right? That has a y-intercept of negative 17, and then a slope of 3. So you go up 3 over 1, and just do a bunch of dots. Okay, so there we go. So there's that line. And then this one is not in y equals mx plus b form. So let's change that. So subtract 2x and divide by negative 3. And then you get positive 2/3 x. And then negative 12 divided by negative 3 is positive 4. So you have a y-intercept of 4 and then a slope of 2/3. Then you see that point that I did mark earlier is the point of intersection. And then there's my line. Ugh. Okay, so for this next one, they're both set equal to y, so we'll set them equal to each other. And since you get a quadratic when you do that, you want to set it equal to 0. And then you get x squared, minus x minus 20. And then this easily factors because there's nothing in front of the x squared. So then it's negative 20 goes up here, negative 1 goes down here. So it's negative 5 and 4. So this factors to x minus 5 and x plus 4. Right, and then what makes those zeros are your x answers, so positive 5 and negative 4. So then you have 2 points of intersection, 5 something and negative 4 something. And then to find what those points of intersection are, it's probably best to plug it into this line. So plug it into this line here. So that's y equals 4 times, and then we'll find the y-coordinate for the 5 point first. So then that's 20 minus 7, which is 13. And then let's do the other one. So then that's y equals 4 times negative 4 minus 7, which is negative 16 minus 7, which is negative 23. Okay, so those are our 2 points of intersection. So 5, 13, so right there, and -4, -23. Okay, let's graph this line first because it's a little easier. So it's 4x minus 7. So that's your y-intercept is -7. And then you have a slope of 4. So you go up 4/1. Okay, so there's my line. So let's graph that. Okay, luckily this parabola, unlike the one on your classwork, does factor, I think. Oh, actually, no, it doesn't. So we'll just plug some points in. You can use that with Desmos. So, and then so you can plot the points. For 1 is a point. 513 is a point. -9 is a point. 2, -17 is a point. 1, oops. 1, -23 is a point. And obviously the y-intercept 0, -27. -1, -29, -2, -29. Okay, so there's my parabola. There we go. Okay, last set of problems. So this one, you want to set them equal to each other, just like the last one. And then you want to square both sides. And then you get x plus 2. And then the right side, though, when you square x minus 4, right, you need to use an area model. So then you get x squared minus 8x plus 16. And since you get a quadratic, you want to set it equal to 0. And then you get x squared minus 9x plus 14 equals 0. Ooh, and that one does factor. Yay! And you get You can do the easy factoring because there's nothing in front of the x squared. So you put 14 here, negative 9 here, negative 7, negative 2. And then you get 2 and 7. And then 2 is extraneous because if you plug 2 in here into the original problem, you'll get a square root equals negative 2, like when you do 2 minus 4. You can't have a square root equal a negative number. If you plus 7 in, right, you get the square root equals 7 minus 4, which is 3, so that does work. So I'm at a point of intersection of 7 something, and then plug it in here, you'll get 7, 3. So here is my point of intersection. And then we'll graph this line first. So that has a y-intercept of negative 4 and then a slope of 1. Oops. So there you go. And then x minus 2, that's just the graph to the left too. So it's right there. So here is my graph. Okay, so now this one's an equality. So this one here is an absolute value, so it's the V shape that has a vertex of negative 4, negative 6. So the opposite of this, and the same as this. So right here. And then this 1/2 is the slope of the right side. So I'll plot that. And then you just reflect it here. And then since it's less than or equal to, it's solid. And then you shade below. Okay, and then this one's a parabola with a vertex of 2, 5. So plot 2, 5, and then it's upside down parabola. And then it's dotted. Because it's just greater than. And then you shade above. So again, you'll notice that you end up getting like these areas as the overlap. Okay, so writing a system, these are lines. So first, this one is dotted and shaded below, and it has like colors. Okay, it has a y-intercept of 4 and a slope of, it looks like, negative 1/2. So it's dotted and shaded below, so that's less than. And then for this one, this is also dotted. It looks to have a y-intercept of 8. And then it looks like it has a slope of 3/2. And so it's shaded, as you can see, like above this line, so, and dotted, so greater. Okay, and then that's your system. Okay, now let's do this one. We'll do the line first. So it's dotted and has a y-intercept of 3. And it looks like the slope is just 1. So it'll be x. So then it's y, and then so you can see it's shaded above the line. So it's just greater, not greater than equal to, because it's above and dotted. And then here, for the parabola, it's dotted and has a vertex of -4, 6. So it's x plus 4 squared plus 6. And then it's shaded above the parabola and dotted, so greater than. And that's your system.